We are now in section 9.3, and looking at 9.3, you see by the title it mentions the complex plane, and then it mentions this theorem, de Moivre's theorem. So this is going to be the first video of 9.3, along with the videos that are available inside MyLab Math. But what I wanted to point out in this first part is anything that I've highlighted in kind of a yellow, a little orange-ish. But the big thing you've got to know on this section 9.3 is you have to be fluent or fluid or versatile, that you're going to be able to convert between a complex number, to take it, to turn it into a rectangular, or to turn it into polar, or to turn it into exponential, and kind of bounce back and forth among all four of these. So we're talking about this complex number, complex plane. Can you convert it to a rectangular form? Can you convert it to polar? Can you convert it to exponential? So the videos that go along with this book are very good. I just want to highlight a couple of other items. Like, when you see this formula right here, notice that I've added a couple of things to it. I've combined this formula up here with it down here. But you'll also notice I said, think about this and write it on our formula sheet. You know that you have a formula sheet for our class that you can use on select tests, and this is what I mean by the formula sheet. There are 2 pages, one with a unit circle and another with just a whole lot of stuff going on the back side. So I would take maybe a side piece or just some place on this, but it's not 4 pages like the front of this one and a blank back and the front of this one and a blank back. It's just 2 pages. And we're trying to condense a lot of information here that you will find very helpful as you go through your next courses. So I would take a moment, I would hit pause, and I would take a moment to write this formula or set of information really down somewhere on your, not answer key, your formula sheet. And so notice I put the R here, and I put the R here. And notice here it's called magnitude or modulus. Most of the time we'll call it magnitude. And notice that that looks like absolute value of z. And earlier you're going to hear that we're going to call a complex number z. And so there are some pieces and parts that you have to be, as I said earlier, fluent. You got to be fluent to know, well, modulus is this, or magnitude is this, or either word's going to work. And it's also this. Well, they're both also this. I have to be fluent to know that all of these mean the same thing, and then go pick up the one that I need for the current situation or problem I'm dealing with. And so down here at the bottom, I would also encourage you to write this information on your formula sheet, because z, our complex number, right here is where you see x and y. That's rectangular. And then when you start throwing in r's and thetas, as you see they come from here, and again this is explained more broadly in his video, and then you get to here and there's your r and your thetas. That's going to be our rectangular, this is going to be our polar. Remember, all I wanted to do with this video was just hit some highlights at the front of this section. And so another one of the highlights, it's not on his videos. And so right here, you see this word, and if you live anywhere in the Houston area, this one's going to be easy to pronounce because we used to have the Houston Oilers, and that's how you say his name, Euler. And so Euler is, and you see information about him, Leonhard Euler, and he has a formula. But more specifically, I need you to write this formula on your formula sheet. So somewhere you've got your complex area going, and that a complex number could be this. Oh wait, that's polar. We just saw that. Oh yeah, we just saw rectangular too. Well, I've got to add a new one. Euler's is going to have r, okay, we saw that on the other page, modulus or magnitude, and it's going to have a theta, but everything gets shifted to the exponent and it's using e. And so a couple of things to underline right here. When we are using Euler's formula, it's considered exponential. You need to remember theta is going to be real and that theta is in radians. And so I'll go ahead and take another second to go right back over here and say, in this entire 9.3, you have got to be fluent. how to go between complex and rectangular and polar and exponential. You got to be able to go back and forth. What do you have? What do you need? What can you use? You got to be fluent. You got to make it all make sense to you. And here goes part of that sense making. And so he does this example 2 on the video, or one like it. And so you can go back and then do this one based on how he was doing in the videos. But I do want to point out something. Inside your book, they are going a different direction using cosine and sine. And I like to use that, how do we find our angle? Well, it's the inverse tangent, and I like to use y over x and then go wherever that is in what I graphed. So the first thing I always do is graph. And if I've got, let me find a pen here. If I have z looking like this, I've got to know that that's rectangular, that square root of 3 is my x and negative 1 is my y. And so right here, if I go over about-ish square root of 3-ish and down about negative 1, I'm sitting in the 4th quadrant, and that's going to help me to know which tangent that's a negative that I pick from. So it all goes together, and that's why I keep saying you've got to be fluid. You just got to be in and out of graphing. No, it's rectangular. Oh, wait, it's polar. Oh, wait, now we need to go to exponential. So this is what's not on his video. And so if you notice, I have pieces here, a theta and my r. My r is 2, and my theta is 11 pi over 6. All I got to go do is grab my formula for my complex number and exponential form, r times e to the I times theta. And then I'm going to go right down here, and in your books, it shows this. It's just not on his video. The exponential form is, so there's a rectangular. Well, that's awesome. But what I really need to know is what's my r and what's my theta to plug into that formula. So my z is r times e to the I times theta. And then when I look here, my r is 2, remember right up here, e times to the I times the, and I plug in my theta. I don't particularly care how they have this written. I prefer 2 times e to the I times 11 pi over 6. I think that looks better, but they're going to write it this way. You may write it that way. I just think this one looks better. The other thing I wanted to show you is when he does example 3, he has different numbers, but he doesn't include the exponential part. But hey, now you know what it is. You got your r and you got your theta. So that's even a quick well, it's already there. A quick conversion back to polar with your r and your theta. I can't say it enough that you've got to be fluent or fluid, whichever way you want to say it, or whichever way you want to see it. But as you go through section 9.3, you've got to be very well versed in taking complex numbers to rectangular, or rectangular to complex, or to polar, or back to exponential. You just got to have it going on to know how to get back and forth, what you have and what you need, and definitely where you're going.